Morning, guys. Today we are going to be using factor puzzles to figure out some proportions. Now, two equivalent ratios make a proportion. So we need, when we're thinking about proportions, two equivalent ratios means like they're going up at a constant rate for each time. It's kind of like an equivalent fraction. All right, so any two rows from a ratio table make a proportion. In a proportion problem, one of the four numbers is unknown, but you can solve it because you have three knowns. And because everything's working together on this ratio table, we know we can find that one unknown number. So in this case, we have Grandma, and she made applesauce using the same number of bags of red apples and bags of yellow apples. Her red apples cost $6 and her yellow apples cost 14. Okay, so now down here we have a factor puzzle with Grandma's. Okay, so we had red apples to yellow apples. She used it cost her $6 for red and $14 for yellow. Now, I used her recipe but made more applesauce. I paid $35 for yellow, and we're wondering how much did I spend on red apples? Now, you need to ask yourself, why is 35 in this part of the factor puzzle? The reason 35 had to go in that part of the factor puzzle is because I spent $35 on yellow apples. It needs to be lined up with the amount that Grandma spent on yellow apples. In order for it to be growing, we need to have it on the same exact side. Okay? Now, if we're going to solve, we have 6 and 14. So I know a factor for 6 and 14 is 2. I'm going to start with that. All right, so 2 times 3 is 6. 2 times 7 is 14. 7 times 5 is 35. Now I have all of my factors. I can figure out what my unknown is here now because I do 5 times 3 and I get $15 for my red apples. Now, that's using a factor puzzle to figure it out. Now, if you don't want to use a factor puzzle, we can come up here and fill out our ratio table. Okay, so for Grandma, when she used 2 bags, she spent $6 on red and 14 on yellow. Okay, we want to be able to work that down to a basic ratio. Okay, so 6 and 14 again are both have 2 as a factor. So if I do 6 divided by 2, I get 3, and 14 divided by 2, I get 7. So 3 and 7 are both prime numbers. I can't get any smaller with that. Okay, I've reduced it down to its simplest form, so that is what I'm going to put here. Okay, $3 for red if we're only buying one bag of each, and $7 for yellow if we're only buying one bag of each. Okay, here we times that 3 by 2 to get 6, and we times the 7 by 2 to get 14 because they bought 2 bags of each. Now, if we keep counting by 3s, okay, we get all the way down to 9 bags. And here, if we count by 7s, we get down to 9 bags as well. Now, there's a spot right here. It's not really part of my question. However, if we go and find the 15 to 35 that I spent on my ratio table, it's right here. It shows up right here. Okay, so how many bags of each type of apples did I buy? Okay, I spent $15 on red, so 3 times 5 equals 15, and 5 times 7 equals 35. So that tells me that I actually got 5 bags of each for my applesauce. All right, last one here. Okay, so now Noreen saved $20 while Tim saved $35. So I'm just going to go ahead and start filling in my factor puzzle. Noreen is up here, Tim's here. So Noreen was 20, Tim was 35. And when Noreen has saved 24, how much will Tim save? Now, it's really important to stay organized in this moment, okay? Because Noreen spent 24, we need the 24 to go in Noreen's column. We need it to go right here, okay? What I'm looking for, the unknown I'm looking for, is how much Tim saved when Noreen saved 24. So let's just do a typical factor puzzle. I see 20 and 35. I know 5 is a factor for both of them. So 5 times 4, 5 times 7. Oops. Okay. 7 shouldn't be there, excuse me. Okay, and then 4 times what is 24? 6. 6. Okay, now I have all of my factors. So now 6 times 7 is 42. So each time Noreen saves $24, Tim is going to save 42. Now, if we got that down to the basic ratio, here it is. Okay, 7 is a prime number, so we can't reduce 7 anymore. So every single time Noreen saves $7, you know that Tim's going to save 7. Okay, now fill in the ratio table, circle the rows that make the factor puzzle, and write the multipliers for those rows outside the table. Now, they don't have a space for that, but we can do it using the basic ratio we formed. Okay, so if we have Noreen and Tim, and we know the basic ratio is 4 to 7, we'll put that on the top. And then I'm going to just start counting by 4s. I'm going to start counting by 7s. Okay, now here it said when Noreen saved 24, Tim saved 42. Now, this was 1, 2, 3, 4, 5. Oops, excuse me. 1, 2, 3, 4, 5, 6. So this was the 6th time that Noreen was saving money. First, she saved 4. And then 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. But on that 6th time that she saved money, 4 times 6 is 24. And so Tim, assuming these are all proportionate, equivalent ratios, 7 times 6 is 42. Assuming that he was saving 7 each time she saved 4, this is where Tim would be. All right. I lie. There's just one more. All right, so here we have 2 scenarios, and we're just having to figure out, like, what are some of the things that actually we're, like, depending on. Like, we're assuming some things if we think these are going to be proportionate. So here we have 2 bands, and they march in rows onto the football field. When band A has 15 people on the field, band B has 6. When band B has 14 people on the field, how many people will band A have? Now, right here it says when band B has 14. Okay, now because this is the side where band A is staying, since we said band B has 14, 14 has to come on this side. So I'm going to put it under the 6. Now I can go ahead and just solve my factor puzzle to figure out what the unknown number of band A people are on the field. Okay, so if I have 6 and 15, I know that both of those share 3 as a factor. So I'm going to start with 3. 3 times 5. 3 times 2. 2 times 7. All right, I've got all my factors. Now I'll go ahead and solve for my unknown. I have 7 times 5 is 35. Okay, so when band B has 14 people on the field, band A is going to have 35. Okay, now this is my basic ratio right up here, 5 to 2. So we are working under the assumption that every single time band B has 2 people walk onto the field, band A will have 5 people walk onto the field. Now, if that doesn't go as planned, if that's not true, these ratios are not going to be equivalent or proportionate. This basic ratio needs to stay true the whole time for all of these to stay proportionate. Okay, this is going up 2 each time, this is going up 5 each time for them to be proportionate and equivalent. Now, next one, we have Joshua has 32 angelfish for every 12 snails he has. So I'm just going to label it A for angelfish, S for snails. Okay, now for 32 angelfish, 12 snails. My angelfish are on this side, my snails are on this side. How many snails will he have when he has 72 angelfish? Now, because it's angelfish, it needs to be on my angelfish side. So I'm going to put 72 right here. All right, so let's try solving this. Okay, we have 32 and 72. Now, if I started listing factors for all of these, I know that 8 works for both of them. I know that 8 times 4 is 32. 4 times 3 is 12. 8 times 9 is 72. Now I've got all my factors, so I can solve for my unknown. How many snails does Joshua have when he has 72 angelfish? 9 times 3 is 27. Okay, so things that we're assuming. We're assuming that things are moving at a constant rate so that all of these ratios are proportionate, okay, or equivalent. We are assuming that every single time Joshua adds 8 angelfish, he is adding 3 snails. If for some reason that gets off, these are no longer proportionate, no longer equivalent. We have to assume that he's always adding the same amount each and every time. All right, so good luck today. You're going to be focusing more on the proportionate pieces of this today in your IXL. So I wish you the best. See you guys.